Hello ladies and gentlemen, welcome to our first video on packet 5. Here we're looking at in and out and all about. We get to talk about some area and perimeter on the coordinate plane just like it says right there. This first video is just going to be for the warm-up and for the getting started portion of this packet. I'm going to work through all of these. In order to do that, I have an extra sheet of paper here. I do think it's helpful on these warm-ups to have an extra sheet just so that you can have space to work it out instead of having to do it all in that little space that they provide for you. So this first one says warm-up, determine the distance between each set of points, round your answer to the nearest tenth if necessary. Okay, so if you'll remember our distance formula, d is equal to the square root, and we have a gigantic square root right there, and we have x2 minus x1, all of that squared, plus y2 minus y1 with all of that squared. Okay, so this means that for a distance formula we need two ordered pairs in order to do a distance, or to do this distance formula. Okay, lucky enough for number one, they gave us two ordered pairs here. Okay, so I'm going to go ahead and do this so that I have x1, y1, and x2, y2 for those 2 points. Okay, this means that for number one, okay, the way I'm going to set this up, this line, this distance here is going to be equal to, it's going to be equal to x2 minus x1, so negative 4 minus 2 squared, plus now y2 minus y1, so 1 minus negative 3, 1 minus negative 3. Okay, quick note on this, I like to put, when I'm subtracting negative numbers, I like to put the negative number into the parentheses just so that I can see that a little bit better. This isn't something that you have to do, just something that helps me see that, okay? So now we're going to start doing some math, simplifying this, okay? So we still have the distance is equal to this big long square root. Now we have negative 4 minus 2, which is negative 6. Okay, we're still going to need to square that in a second. Plus 1 minus a negative 3. Subtracting a negative is like adding a positive. So this is going to be like 1 plus 3, which will be 4 squared. Okay, so now we have, sliding down here just a little bit more, we have this distance is equal to, still under the square root, okay, we just can't forget that. Negative 6 squared is negative 6 times negative 6, 36, plus 4 squared, which is 16. Okay, so now we have distance is equal to the square root of 52. I didn't need to do quite such a big square root there. Okay, and then I have my calculator over here off on the side. The square root of 52 is 7.21. Okay, and our answer did say rounds to the nearest tenth, so actually I don't even need this one, and our final answer here would be 7.2, and that is for the first one of our warm-up. Okay, so now we're going to look at number 2 now. Okay, so I'm just going to slide this paper over. Okay, so our distance formula hasn't changed. This time I'm going to use x1, y1, x2, y2. Okay, for my coordinates. So that means that for number 2, okay, our distance is going to be equal to, and I won't rewrite the distance formula, but it is the same, nothing has changed here. So we're going to go open parentheses, x2 minus x1, so 3.25 minus, and then again, like I said, when I have negative numbers, I like to put them in an extra parentheses, so 4.75, all of that squared. Okay, so that's just our x's. So plus, and then in a new parentheses, y2 minus y1. So this time it's going to be 5.5 minus, and then again, negative 8.5. I like to put that in parentheses, okay, just so that I can see that a little bit better. So this looks big and ugly. It's got a lot of decimals, but actually it works out to be okay. Okay, if I drop down a line here, I still can't forget that square root. So 3.25 minus a negative 4.75, we said that subtracting a negative is the same as adding a positive. So 3.25 plus 4.75 is going to be 8. Okay, and we still need to square that in a second. Plus, now we have 5.5 over here minus a negative 8.5. Again, subtracting a negative like adding a positive. So 5.5 plus 8.5 is 14. And we need to square that. Okay, now squaring both of those numbers, 8 times 8 is 64, 64, plus, and then I don't know 14 squared, so I'm going to throw that in my calculator really fast, 196. Okay, if I add those together, I'm going to end up with 260. Remember, we still need that square root, so 260 here. And then, so the square root of 260, again, got my handy dandy calculator off the screen here. Oops. Sorry, 1 second. Here we go. Okay, after we're using that handy dandy calculator, okay, we got 16.12, and again, we actually only need to go to the 10th, so our answer here would be 16.1. Okay. Now looking at number 3, okay, I'm going to have 5/4 and 9/4 for my first ordered pair, and then 0, 10. So I'm going to just flip this over so that I can keep doing like I've been doing. Sorry that you can see through that a little bit. I promise that we will get through this together. So now I have x1, y1, x2, y2, just like previous ones. Okay, so my distance here, again, is going to be equal to this long square root symbol. I'm going to do x2 minus x1 in my first parentheses, so x2 is 0, minus x1, which is 5/4, all of that squared, plus y2 minus y1, which is 10 minus 9/4, all of that squared. Okay, so now dropping down a line, 0 minus 5/4 is just negative 5/4. Have all of that in some parentheses. We're going to need to square it in a second. Plus 10 minus 9/4. Okay, the way that I do this in my head, now if you want to, you can use a calculator. The way that I do this in my head is I know that 10 is the same as 40/4, because if I have 40/4, if I had like 10 pies, or 10 pies, well, yeah, 10 pies, and I cut them into 4 pieces, and I had 10 of those, I would have 40 total pieces, right? So 40/4 minus 9, 40 minus 9 is 31, all over 4, okay? And then I'm going to take that number, and I'm going to need to square it in a second. Okay, so I don't advise you trying to do 31 squared in your head. You are more than welcome to if you'd like. The way I'm going to do this, I know that 5/4 squared is 25/16, plus 31/4 is the same as 961/16. Okay, so now I want to simplify what's under this square root here. So I'm going to do 25 plus 961. Gives me 986 total. Now remember, we haven't done anything with our square root, so that's chilling. So we have 986, and then both of these are over 16, so those are 16ths, or that 986/16, okay? Now I'm going to get that into a decimal form really fast. So that means that this, okay, this distance now, remember we still haven't done anything with the square root, is 61.625. If you wanted to round here, you could. I don't like to round until the very, very end of my problem, though, because then it'll give me a more accurate answer. Okay, so then I'm going to do the square root of this, which I get to be 7.8, well, 7.9, because we're going to the 10th. So it was 7.85. That 85 makes me round up to 7.9. Okay, so there are your 3 warm-up problems. That was number 3, in fact, okay. Now we're going to flip over this page, okay? So we did the warm-up, now we're going to flip over this. If you're following along, we're on page M170, okay? We're looking at these 2 shapes, and it says, describe a way you can use the grid to determine the area of rectangle JKLM and triangle NOP. Okay, so the way that I'm going to do this, so this actually is we're going to do some secret distance formula, only the problem is we don't have coordinates for these points. We just have locations on a grid. So I can't plug it into the distance formula, but we can do something similar. If you guys remember in class, or if you remember from past classes or anything, okay, we can say that we know that Pythagorean theorem is very similar to distance formula. So if I go ahead and construct a triangle right here, and then I count units, okay, this height here, or this going up, 1, 2, 3, 4, 5, 6 units. This is 6 units tall, and 3 units across, or with a base of 3 units. Okay, and so we say that we're describing a way that you can use the grid to determine the area of each of these things. So I don't need to actually do any calculations, but to find the length of this side, okay, to find the length of this side, I would need to do this. I would need to use this right triangle, which would give me the length of JM. Is that a J? Yeah, JM. Okay, and because this is a rectangle, that means I would also have the length of LK. Okay, so now I have 2 lengths here. And then I would do the same thing. I would construct a different right triangle. Okay, I would construct a different right triangle. This one goes down 1, 2, 3, 4, 5, has a height of 5, and goes over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so then I could use this triangle to find the length of LM. LM. And then LM is the same length as JK, again, because it's a rectangle. And so one important thing to note here, we know that the area of rectangles is base times height, or another way that you've seen it sometimes is probably area is equal to length times width. Okay, those are both for rectangles. So once I have the length of two of these sides, so JM and ML, I can multiply those two things together, a base and a height, a length and a width, and then that would give me my area for the rectangle. Now looking at this triangle, okay, there's a couple ways that we could do it. Now, the first thing though, before we do that, I'd like you to remember your equation or your formula for area of a triangle. Most commonly, you'll see it like this. Area is equal to 1/2 base times height. Another way you could see it written is area is equal to base times height divided by 2. And lastly, you could also see it written, and this is kind of a weird one. I don't know if I've ever seen it written this way, but it technically is correct. Area is equal to 1/2 the height times the base. The reason that we can do that is because this 1/2 base times height is the same as, okay, so just come down here, it's the same as 1/2 times base times height. And when we have multiplication, we can flip them around any way we want because our order doesn't matter with multiplication. Just like 2 times 3 is 6 and 3 times 2 is also 6, we could flip these around in any order we want. So if I flip, so this 1/2 BH is the same as this. This form over here is if I flipped my B and my H. And then this last form is if I multiplied B times H first, and then I multiplied that all by 1/2. So another way to write that, okay, would be 1/2 times the quantity B times H. So that's what this form is kind of looks like, okay? I personally like this form or this form most. Like I said, I haven't seen this one very often, but it is something that you can see or that you can use, okay? So for this problem, to find the area of this triangle up here, area is, we need a base and a height, okay? We said that area, sorry, down here, very bottom of the screen, area equals 1/2 base times height, which means I need a base and I need a height. Okay, in order to find the base here, I would just pick this PO. Okay, so PO, this would be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, I believe. Okay, so my base would be 13 there. And then a height, and this will actually come in later in the video as well. My height is just going to be, so from the base, we look at the highest point on the triangle N, and then I can just draw a line straight up from this base that matches the highest point, okay, that matches the highest point, and then count that. So I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So base of 13, height of 10, and then I could throw those into my formula and calculate that out. Another way that you could do it, and the way that we did it, a few people did it in class, okay, is if I take this triangle and I make, and I draw around it, I draw a rectangle. Because this is kind of an oddly shaped triangle, the one that they gave us, the way that we did it in class, or that we talked about in class, was doing this rectangle, and then we could calculate the area of this triangle, we could calculate the area of this triangle, and then we could subtract both of those from the total area of the rectangle, and that would also give us the area of this triangle. So there's a couple different ways that you can look at this. So yeah, there you go. This was the first part of Packet 5. This was the warm up and getting started section of Packet 5. Please ask me any questions that you have in class. I hope you guys have a wonderful day, and I will see you soon.